Hello everyone, myself Ashish Desai, Assistant Professor, Student Institute of Technology, College of Engineering. Today we are going to discuss on the topic of additive manufacturing. So, additive manufacturing is nothing but a 3D printing, which is process for creating the 3D dimensional object by depositing the material layer by layer. So actually we are having the two manufacturing areas are there. So one is subtractive and second is additive. In subtractive manufacturing, we are removing the material in that concept, but in additive manufacturing, we are adding the material over here. So there is no wastage problem in additive manufacturing. So actually the importance of that, it enables for the rapid prototyping. Easily we can differentiate or for the customization and complex geometries. So this is the importance of the additive manufacturing. So there are three 3D printing works. So first of all, we create a model into the CAD software. So which is 3D CAD software. You can say the Fusion 360 or any CATIA, SolidWorks. So any 3D model software we can use this and we can create a 3D model. So this is the criteria we are doing the work over here. Second is you are using the slicing software, so which is convert from the this 3D model into the layer by layer printings. So that is from called as a .stl file to the convert to the layer by layer printing. The third is the printing process. To printer we can deposit the material layer by layer, and after that we can take a post processing for the after the finishing of your work. So we can take care by the that is by sanding and painting. So this is about the post process for the 3D printing works. So there are different 3D printing technologies are nowadays we are evolved with this. So one is the fuser deposition modeling, that is called as FDM. So which is useful for thermoplastic filaments. So different filaments we are using over here, that is like PLA material, or can say that is ABS material we can use over here in a FDM technology. The next we are using the stereolithography. This is the most convenient technology for using a liquid resin, and we are using the UV lights for the propagations, and then we are uh, create a layer by layer technology over here. The next is selective laser sintering. So here powder material is used with a laser, and we are creating the possible shape over here in a SLS. Then fourth one is binder jetting. So it is use of fuse powder material. So we are using the fusing of the powder, and then we can find our object over here. The next is about direct metal laser sintering, so it is useful for the metal parts. So these are the 3D printing technologies are evolved with us. So firstly, one by one we discuss over here. So firstly, that is about fuse deposition modeling. So here we are discussing the there that is filament spool. So we are wounding the material over here, that is in the form of wire, and that is we can call as filament. So which is wounding over here, and this is a nozzle, so which is called as extruder. So in that case the extrusion is possible. So in that case we are having the that heating block we are called as a heater is there, and cooling fan also required over here for cooling the material. So if it is excessive temperatures built up over there, then we can use the that cooling fan will be on and the temperature will be maintained. So this is why we are called as extruder. And layer by layer it can be formed, that is called as the fuse deposition modeling. So here not sticking with printing, that is why the bed also we can hit it. So this is non-sticking printed bed, so here also heating is required, and nozzle is also required heating is there. So for heater purpose we require up to temperature is up to, for extruder purpose it requires up to 210 or 220. And for bed purpose, so this is bed, so bed purpose we require to be 60 to 70 degree temperature, for it is not sticking to the part in on a surface. So this is about the fuse deposition modeling. Second is about stereolithography. So here the liquid resin is present. So this is a container, and which is having the liquid is present. The laser sources, so we are having the laser source, and which is poising mirror. So we can getting the required shapes over here. For heating purpose it can be heated, and then the layers will be formed. That is about the built up platforms we can doing over there. That is about the stereolithography. And then selective laser sintering is there. The selective laser sintering is a 3D printing technique that uses a laser to fuse powder. So here the material is about the powder form, and we are the laser sintering or laser giving the fuse powder materials, and solid structure is there we can form over here, and that is the called as a SLS, that is selective laser sintering. Then nextly we are discussing the binder jetting. So here wider supply we have that technology, so it is liquid adhesive form, so to create the object from the digital data. So it is in the format of 3D printing, that is about binder jetting. Okay, so that is fabricated parts is there. So here the powder form is there, so rolling action is doing over here, and the binding of the materials which is causing by the this roller action as well as the heating action. So this is printer head, and after that we can forming your fabricated objects. The next is about direct metal sintering. So here that is about DMLS is printing techniques that uses the built material parts from the powder. So it is also known as selective laser melting. So here the powder metal parts is from the powder, and then we can build up by the laser. So this is the direct metal laser sintering, which is useful for the metals. The material used in 3D printing. So mostly the thermoplastic material, that is ABS, PLA, and this nylon material. It is useful for FDM, and the metal printer, that is DMLS and binder jetting. We are using aluminum, titanium, and stainless steel. Ceramic also we are using for the industrial applications. The next is about composites, also used in this case, that is carbon fiber material for the adding strength. So we are using the infusing materials over there, and then we are adding the strength over there. Then biomaterials is there, which is useful for the medical applications for implantation and prosthetics. The next is there are different areas we are using the 3D printing nowadays, though such a aerospace industry, automotive industry, medical and healthcare industry, construction industry, and education and research. So different industries we are using the that 3D printing technology. So nowadays 3D printing houses are also present. So also we are using in a research area, so we're developing the different structures and where areas are there, so we can finding in the 3D printings over there. Medical healthcare industry also we can implementing the different plants of the that parts of the body, so we can with the making with the 3D printing. This is also we the having the different advantages of 3D printing. One is a customization, so which is enabled for the personalized design. So anywhere design is are present, we can design and customize it in product over there. Reduce the waste because of the uh, addition of the technology, that is additive manufacturing is there. That's why the metal is loss less, or you can minimize this. The rapid prototyping, that is faster product development we are possible over there. Then complex geometries, so every time integrate designs we can possible in a 3D printing. The cost efficiency also there, that is reduces the manufacturing cost because we are required in a smallest batches, and you, as well as the less material waste is there. Material waste is less, so that's why we are in a cost efficient manner. Different challenges also associated with the 3D printing. So sometimes we are having the materials limitation, that means metal is not available. Then printing speed is also slow because for the large scale productions. Then post processing needs, so after the completion of our object or any part, so we require the pre-processing or post processing is required. Then the equipment cost also can be expensive, and some intellectual property issues also, that is unauthorized duplication is also possible. So these are main areas or the challenges. So now we are having the new feature for the 3D printing, that is advanced in a bioprinting, that is printing functional tissues and organs, so is also possible. Then sustainable 3D printing, which is useful for the recycling and materials also possible. Then integration with AI and IoT, so smart manufacturing areas we are using 3D printing also. Nowadays we are also built up for the future of 3D printing in a large scale industry, so entire building and infrastructure we are developing with the 3D printing, so it also possible. So that is the future areas in 3D printing. So this is the here the application in architecture. So different areas or different shapes or customized shapes you can formulate. So different complicated shapes we are forming over here. This is a look like a benches. This is some green picks for the architecture model. So we are any type of shapes we can form over here. So this is lamp of lightings, and then we can see the architects over here forming different structures. That is sculpture structures also form here. The next is about other applications. So nowadays we are food preparations also doing with this 3D printing, and we are also forming a mud type, so we can say mud 3D printing also available. So different mud structure you can form also there. Then next is medical industry. So 3D uses 3D printing to making a hearing aids and artificial teeth and bone crafts also we are forming, that is So here in the glimpses of 3D printed jaws also present nowadays. So this is a hearing aid we can use for the human being, and which is forming by the 3D printing. Also we are forming any broken up of the bones, so that is medical orthopedic casted, and then we can use full for that. So there is called as a rehabilitation devices, so which is assistive type of work we can form the this type of 3D printing. Then nextly we are having the conclusion and takeaways. So different conclusions is available for the 3D printing. So 3D printing is a revolutioning industry with its versatility and efficiency. Continuous advancement will drive its application in sectors, and the future holds the potential for groundbreaking and innovation in manufacturing healthcare. So these are the main areas nowadays we are going to this working in a 3D printing. So thank you